morning, students. Today we are starting the second topic of NCERT for class 12, inverse trigonometric functions. Inverse. When the word inverse used for the function, so we are clearly in the domain that a function is said to be invertible if it is 1 and onto both. Okay? Suppose that a function is defined from f, function f is defined from the set x to set y, written as f x to y. Then x is called domain, y is called codomain, and the element of the set y, which are the images of the element of set x, are called the range. So range of the function may be the proper subset of the codomain or may be equal to the codomain. In the case if range of the function is proper subset of the domain, in this case the function becomes into function. If the range of the function is equal to the codomain, in this case the function will be onto function. So we are taking trigonometric function whose inverse in this chapter we are going to define. Suppose that fx plus sin x is a function. The total graph is given there, but we highlight the area between x equal to minus pi by 2 to x equal to pi by 2 for fx equal to sin x. We know that well. If the function is defined from set of real number to set of real number, so sin x is neither 1 nor 1 2. That means inverse is not possible. But here we are using the word inverse trigonometric function. That means this function have the inverse. So what is the condition? So in this position between minus pi by 2 to pi by 2, we clearly in that the function is 1 and onto both. So this is a restricted domain in which the function is bijective and the sine inverse and the inverse of the function is adjacent. So here let y equal to sin x be a bijective function, then x equal to if we are assuming here y equal to sin x be a bijective, that means we are taking a restricted domain here. Then x equal to sin inverse y, read as x sin inverse y. Here sin inverse x not equal to sin x whole inverse, not equal to 1 upon sin x, not equal to sin 1 upon x. So that means the sin inverse x is the particular inverse of the function sin x. Similar condition is going for the cos x, tan x, cot x, sec x and cos x. So this particular restricted domain, when we goes from f x to y, this is domain, this is codomain. In the reverse order for f inverse y to x, this become domain and this become codomain. So now the particular restricted domain for sin x in the sin inverse part become a principal value branch. This is the domain and this become a principal value branch. So for there are some inverse trigonometric function, sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, cos inverse x, cosec inverse x, sec inverse x and cosec inverse x. Here the domain of sin inverse x minus 1 to 1, principal value branch minus pi by 2 pi by 2. Similarly for cos inverse x, closed interval minus 1 to 1, principal value branch 0 to pi. Tan inverse x, set of real numbers, open interval minus pi by 2 pi by 2. Cot inverse x are 0 to pi. Similarly for sec inverse x and cosec inverse x. So these are the domains and principal value branch for the trigonometric function. Before starting this chapter, I am going to recall some basic concept of the trigonometry which are used in our class 11. These are sine minus theta equal to minus sin theta, cos minus theta equal to cos theta, tan minus theta equal to minus tan theta, cot minus theta equal to minus cot theta, sec minus theta equal to sec theta, cosec minus theta equal to minus cosec theta. Similarly, sin 90 minus theta equal to cos theta, cos 90 minus theta equal to sin theta, tan 90 minus theta equal to cot theta, cot 90 minus theta equal to tan theta, sec 90 minus theta equal to cosec theta, cosec 90 minus theta equal to sec theta. Next, sin 90 plus theta equal to cos theta, cos 90 plus theta equal to minus sin theta, tan 90 plus theta equal to minus cot theta, cot 90 plus theta equal to minus tan theta, sec 90 plus theta equal to minus cosec theta, and cosec 90 plus theta equal to sec theta. And one more category we are discussing here, sin 180 minus theta equal to sin theta, cos 180 minus theta equal to cos theta with minus sign, tan 180 minus theta equal to minus tan theta, cot 180 minus theta equal to minus cot theta, sec 180 minus theta equal to minus sec theta, and cosec 180 minus theta equal to cosec theta. These are some concepts we are studying in class 11th. There is no need to learn or remember, you can find them easily. Suppose that we are discussing here about this one, sin minus theta. We know that well, the minus angle will come an angle when the angle is moving clockwise. So suppose that this is the point P, an angle is given there minus theta. To draw this Pn, this is 90. We want to find the sin minus theta. Why is the reason the sin minus theta is minus sin theta? So here sin, this value is positive x-axis, so become positive. This is negative because it's going in fourth quadrant, and this is the distance is always positive. So sin minus theta equal to, this is the perpendicular Pn upon OP, and Pn is with minus sign, and OP is with plus sign, so this becomes minus of sin theta. Due to this, similarly, if we are going for cos theta, cos minus theta means base ON is positive and hypotenuse is positive, so this becomes cos theta. So this is the reason why the negative sign with the negative sign, sin become minus, cos become positive. Similarly, the sin 90 minus theta is cos theta. What is the reason behind it? This becomes with positive sign. Suppose that we are taking with there. P is the point and this is the angle is coming in first quadrant, and first quadrant sine and cos. So in first quadrant perpendicular is positive, base is positive, and this is always positive. So all the trigonometric ratios are coming with positive sign. For this, sin 90 plus theta, this value is going in second quadrant. This value is negative and this value is positive. So all the ratios they are having base. Are coming in negative sign and remaining are coming in positive sign. Sin 90 plus theta. So perpendicular and hypotenuse are used there. This is positive. But in cos we take here base. So this come with minus sign. Similarly, tan will come with base. Cot will come with base, sec come with base, cosec will come with perpendicular and hypotenuse. So all the ratios in which the perpendicular is used are the positive sign, base are used are becoming with negative sign. So this is the reason why the trigonometric ratio change with this angle are come with positive or negative sign. Thank you. Now next topic in inverse trigonometric function is properties of inverse trigonometric functions. So we start with first sin inverse sin theta equal to theta for every theta belongs to minus pi by 2 to pi by 2. That means the angle should be the part of principal value branch. Second, cos inverse cos theta equal to theta for every theta belongs to 0 to pi principal branch. Third, tan inverse tan theta equal to again theta for every theta belongs to open interval minus pi by 2 to pi by 2. Fourth point, cot inverse cot theta again equal to theta for every theta belongs to open interval 0 to pi. Next, sec inverse sec theta equal to theta for every theta belongs to closed interval 0 pi minus except the value pi by 2. Similarly, last cosec inverse cosec theta equal to theta for every theta belongs to closed interval minus pi by 2 to pi by 2 except 0. These are some self-adjustment property: sin inverse sin theta, cos inverse cos theta. Similarly, one sin inverse x equal to x for every x belongs to domain, that means minus 1 to 1. Second, cos inverse x again equal to x for every x belongs to minus 1 to 1. Third, tan inverse x. This is equal to x for every x belongs to R. Fourth, cot inverse x again equal to x for every x belongs to R. Fifth, sec inverse x equal to x for every x belongs to R minus 1 to 1. And sixth, cosec inverse x equal to x for every x belongs to R minus open interval minus 1 to So these are called self-adjustment property. When we have sin inverse sin theta equal to theta, that means theta belongs to, this may be written as theta if theta belongs to minus pi by 2 to pi by 2. That means all the properties are satisfied whenever the value of angle theta lies in their principal value branch. But these properties are written as in the form of this: if all the values of x lies in domain. Now we are taking some more properties of inverse trigonometric function, that is sin inverse minus x equal to minus sin inverse x for every x belongs to minus 1 to 1, cos inverse minus x equal to pi minus cos inverse x for every x belongs to minus 1 to 1, tan inverse minus x equal to minus tan inverse x for every x belongs to R, 4 cot inverse minus x equal to pi minus cot inverse x for every x belongs to R, sec inverse minus x equal to pi minus sec inverse x for every x belongs to R minus 1 to 1, and cosec inverse minus x equal to minus cosec inverse x for every x belongs to R minus 1 to 1. So these are some more properties for the negative angle in the inverse trigonometric function. Sin, tan and cosec will come the same function with negative sign, but cos, cot and sec come with pi minus cos inverse x, because the principal branch of cos, cot and sec is lying between 0 to pi. Suppose that here we are taking cos inverse minus x. Let cos inverse minus x equal to y. Then minus x equal to cos y, x equal to minus cos y. This can be written as cos pi minus y. So pi minus y, so cos inverse x equal to pi minus y, or y equal to pi minus cos inverse x. That means cos inverse minus x come with pi minus cos inverse x. So how can we verify that the cos inverse minus x come with pi minus cos inverse x? Because cos y and sec y are not negative in fourth quadrant, so we cannot go with the minus sign here. So cos y can be minus cos y can be converted with pi minus y, and pi minus y is the principal value branch for the inverse function of cos. So we take here pi minus y. So this is the reason some function are come with negative sign and some come with pi minus negative sign. Now I am taking some problems based on principal values. Find the principal value of the following. The first question is sin inverse minus 1 upon 2. So how can we solve this type of questions? The part A, sin inverse minus 1 upon 2. First start with sin inverse. It's a basic concept. Sin inverse minus the value of 1 upon 2 in sin is sin pi by 6. Okay. Sin inverse, this can be written minus sin pi by 6 is written as sin minus pi by 6 because sine minus theta equal to minus sine theta, and this equal to minus pi by 6 because minus pi by 6 belongs to closed interval minus pi by 2 to pi by 2. So here we convert this can be written as this, and we convert this value in such a form when this angle comes in the principal value branch of the given trigonometric function. So here minus sin pi by 6, sin minus theta equal to minus sin theta. This also can be written as sin pi plus theta, but we cannot take this value because this value is going outside the principal value branch. So we take only this value sin minus theta. Okay. B part, cos inverse root 3 upon 2. This can be written as cos inverse cos pi by 6 because the value of cos 30 is root 3 by 2, and this can be written as pi by 6 because pi by 6 lies between 0 to pi. Now we take the third part, C part is there, cos inverse minus 1 by 2. Here cos inverse minus 1 by 2, minus is there, 1 by 2 is the value of cos 60, that means pi by 3. Now how can we convert this minus cos pi by 3? Cos inverse, this can be written as cos pi minus pi by 3 because cos pi minus theta equal to minus cos theta, and now this can be written as cos inverse cos 2 pi by 3. The principal value is 2 pi upon 3 because 2 pi upon 3 lies between the principal value branch. Now I am taking one more part, cosec inverse 2. Cosec inverse 2. This can be written as cosec inverse cosec pi by 6. The value of 2 in cos is cosec pi by 6. So this can be written as pi by 6 because pi by 6 lies between minus pi by 2 to pi by 2 except 0. Now I am taking one more part from these questions. This is the G part here now. G. Sin inverse. This is a combined question of two inverse trigonometric function. Sin inverse 1 upon root 2 plus cos inverse minus 1 upon 2. So we take here sin inverse sine of pi by 4 plus cos inverse minus cos pi by 4. There is no problem. This is again sin pi by 4 because our angle is coming in the principal value branch, but here the conversion is needed. Cos inverse cos pi minus pi by 4 because cos pi minus theta is equal to minus cos theta. So finally this becomes pi by 4 plus 3 pi by 4 and 4 pi by 4. So this is the principal value. So these are some questions based on the principal value branch. So we can solve it easily if we remember the table. Thank you.